Welcome to this lab. In this lab, we will perform client-side encryption using the data keys. As we saw in the previous lab, we cannot encrypt a file larger than 4 kilobytes with customer master keys. We can use a data key to encrypt a file larger than 4 kilobytes. Data keys are generated under customer master keys. When we make a request for a data key or to generate a data key, a plaintext as well as encrypted ciphertext data key is returned to us. The plaintext data key is used to encrypt our data and is usually deleted right after. The encrypted data key or the ciphertext key is stored alongside the data. When data needs to be decrypted later on, you first of all decrypt the ciphertext or encrypted data key and use the return value to decrypt our actual data. So let's quickly head over to the AWS documentation for the generate data keys command. So I'm in the KMS documentation once again. I'm going to scroll down and find the command to generate data key. So as you can read in the description, this command returns a data key that you can use in your application to encrypt data locally. Now there's more info about the actual command. For example, you can specify the key, the length of the key that you want to return, and that the operation returns a plaintext copy and ciphertext of the key request, which we already discussed. So you can read these steps on the documentation page. Now you can also return only an encrypted copy of the data key if you want, and for that you use the generate data key without plaintext command. So the actual command looks something like this. You say generate data key, you pass in the key ID, and then you give the number of bytes. That's all we need to make a request for a data key. So let's move back to the command line. So first of all, let me show you the contents of my folder once again. I have two files. One is hello.txt, one is image.png. The image file is larger than 4 kilobytes. So what I have here is a command that's ready to go. It says AWS KMS generate data key. The key ID, I'm passing in my alias of my generated key, and I'm also saying number of bytes, which is a mandatory field that you need to pass, and I'm saying I need a 32 byte key, which is 256 bits. And finally, I'm passing in the profile of the user. So when I say enter, I am returned a plaintext, a key ID, and ciphertext. Now I can use this plaintext to encrypt data, and quickly I'm going to show you how to encrypt data. I can use something like open SSL, AES 256 CBC-in, and I'm going to input the image file, image.png, which is larger than 4 kilobytes, and I'm going to out secret.txt. I'm going to say -k, and I'm going to pass the plaintext key that I was returned. So this is my data key. Once I do this and say enter, when I say ls, then now I have the secret.txt file. Let me try to see what's in there. It's going to be some gibberish. And to decrypt, I'm going to use this command open SSL -d -aes 256 CBC. And for input, I'm going to say secret.txt. That's what we did earlier. And for output, I'm going to say no secret.png. I'm going to pass in the key that we put earlier to encrypt. And now when I list the contents of the folder, I have no secrets.png. And if I open that file, I'm going to see the decrypted. File, no secret.png. And let's check out what the original file was. Image, and this was the original file. So that's how we use the data keys. Once again, to revisit what we did, we first of all generated data keys. We used the plaintext data key to encrypt the data, and we later used the same key to decrypt the data. But when you're doing this for a long run, you probably want to delete that plaintext data key, store the ciphertext data key that was also returned, and when you need to decrypt your data, you decrypt the data key first and use that decrypted data key to decrypt your data. It does sound a little bit confusing, but if you just break it down, it's very simple. Thank you for staying with me in this lab. I'll see you in the next lab.